Okay, so today we actually have a lot of objectives. Today we're talking about proportional relationships. We're going to talk about what the constant of proportionality is in a proportional relationship. We're going to tell, if we look at a graph, we're going to be able to tell from the graph whether a relationship is proportional. We're also going to look at a table and tell whether a relationship is proportional. We're going to interpret graphs, and we're going to use the constant of proportionality, which we're going to learn about in Objective 1, to write equations. Okay, Objective 1, to define the constant of proportionality. The constant of proportionality is just the value of the ratios of quantities in a proportional relationship. Okay, this is the kind of wordy definition that comes straight from your math book. The constant of proportionality is the same as the unit rate. So that's good news. That's not so complicated. You guys already know how to find unit rates. The constant of proportionality is the same thing as a unit rate. It's just called something different. Okay, so the question asks to find the constant of proportionality for the following proportions. So we have two things that are proportional to each other. We already know that these fractions or these ratios are proportional. We need to find the constant of proportionality. So we're essentially finding the unit rate. Let's put this in terms of money. If we bought 1 pound of something for $2, how much could we buy for $1? That's what we're finding out here. Anyone tell me what that would be? Or if we could buy 14 pounds for $28, how much could we buy for $1? Anyone? If I can buy 1 pound of something for $2 and I only have $1, how much am I going to be able to get? Cheyenne? Half a pound. So the constant of proportionality here is, oh no, my screen just went blank. Okay, let's try this again. It's still recording, so that's a good thing. Let me try to reconnect. Interestingly enough, on the video, the screen doesn't go blank because it's recording my computer screen. So you guys here in class can't see it, but the other people watching are probably like, what is she talking about? Okay, it says it's connecting you now. We're back, okay. Okay, so the constant of proportionality, which I'm going to refer to, I'm going to use the letter K to represent the constant of proportionality, and I'm going to express it as a decimal. The constant of proportionality would be 0.5 for that proportion. Okay, next set of ratios. These are proportional. I have 3 is related to 8 in the same way that 1.5 is related to 4. What would my unit rate be for either of these ratios? You can use either one. So to find a unit rate, I'm taking the top, I'm dividing by the bottom, and that tells me how much per 1. Anyone tell me what that unit rate or constant of proportionality would be? Cheyenne?
0.375.
Good, it would be 0.375. So the constant of proportionality for this proportion is 0.375. Okay, what about our next one? What would the constant of proportionality be? You can divide either of those ratios. Anna?
0.8.
0.8, good. Okay, any questions about this? It's just a unit rate packaged a little bit differently. Okay, Objective 2 is to tell whether a relationship is proportional from a graph. This is really easy as long as you remember the rule. The graph of a proportional relationship is always going to be a straight line. Remember when you were doing unit rates on Study Island, all of the graphs that you had to find the unit rate from, they were all straight lines. The other thing that has to be true of the graph is it has to go through the origin. And the origin on a graph is just that point, 0, 0. So it's just the middle where the two axes meet. So the graph of a proportional relationship, number 1 is a straight line. Number 2, it goes through the origin. So if we want to find the constant of proportionality from a graph, it's the same as what we did when we found the unit rate. When we were finding the unit rate, we took whatever was on the y-axis, which is called our dependent variable, and we divided it by whatever was on the x-axis. So I could pick a point like this, where my graph meets exactly in the center. My y value is 4. My x value is 2. So what would my unit rate be? What is it per 1? If it's 4 per 2, what is it per 1? Brian? You look like you're raising your hand, so you get to.
2 per 1.
Yeah, 2 per 1. And we could actually look at that right on the graph. We can actually pick the unit rate right off this graph. So the unit rate is 2. That's the same as the constant of proportionality. So the constant of proportionality is 2. And this section right here tells us the constant of proportionality from a graph is always y divided by x. Whoops, that looks worse. There we go. Y divided by x. Okay, now we're going to look at an example that actually comes from Study Island. Which of the following graphs represents a proportional relationship? So remember those two things. We need it to be a straight line, and we need it to go through the origin. So volunteer to tell me which one of those is a proportional relationship. I see lots of hands on this one. Okay, Max.
Y.
Graph Y. Good. Why is graph Y a proportional relationship?
It goes through the origin.
It goes through the origin and
It's
it's
a straight.
a straight line. So why is W not a proportional relationship? Kayla?
It doesn't go through the origin.
Okay, first of all, it doesn't go through the origin. It's also not just a plain old straight line. It's kind of like a zigzaggy thing. What about X? David, why is that not a proportional relationship? Good. What about Z? Why is that not a proportional relationship? Megan? Right. So they fit the criteria. X and Z fit the criteria of being a straight line, but it has to go through the origin. Any questions so far? Okay. A table of values, when we're looking at a table, it shows a proportional relationship if all of the ratios are the same. So we're just going to check all of the ratios within the table, and we're going to do y divided by x. Y divided by x. And we're going to see if it's the same for every column in the table. David?
Oh,
What's that?
this table is 1/3.
It would be, we're going to do y over x. So for our first column, we're going to do 15 over 5, which is 3 over 1, or just 3. So our constant of proportionality, if it's all the same, is going to be 3. So now I'm going to check to make sure all of them work out that way. So I'm going to check this one. 18 divided by 6 is 3. So far I'm good, but sometimes the tables will start out looking like they're going to work, and then they don't. So you have to check all of them. 21 divided by 7 is 3. We're good there. And 24 divided by 8 is also 3. So this one does represent a proportional relationship. Okay, the next slide asks you which of the following tables represents a proportional relationship. So you need to try all of them. Do y divided by x. As soon as you hit one that doesn't work, you can give up on that table and go to the next table. So I'll give you a second to try this, then we'll talk about it. Okay, good. Most of you I already checked. Does anyone want to volunteer to tell me what the actual answer is? Angelina? C. Good. Correct answer is C. So when we check the ratios on A, 2 divided by 1 is 2, 6 divided by 2 is 3. So we can eliminate A right off the bat. Same thing with B. 2 divided by 1 is 2, 4 divided by 3 is not 2. So we can eliminate that. We check C. 2 divided by 1 is 2, 4 divided by 2 is 2, 6 divided by 3 is 2, and 8 divided by 4 is 2. Everyone works out. If we were really careful and cautious, like I tend to be when I'm doing stuff like this, I'd probably check D just to make sure I hadn't made a mistake in C. And if you check D, you would find out that this last column doesn't work. It's not the same as the rest. But D looks like it would be correct up until that point. Okay. Objective 4 is interpreting graphs. You'll see a lot of questions like this when you're working on Study Island, and this does come from Study Island. A high school band is selling tickets to its concert. The ticket prices are shown in the graph below. Based on the graph, what does the point 440 represent? Remember, in an ordered pair, what does the first number stand for? Does it stand for the x or the y value?
X.
The x value. So this is the x value. This is the y value. Along our x-axis, we have the number of tickets. Along our y-axis, we have prices in dollars. So which one of those choices would represent the point 440? How about if we do it this way? If you think it's choice A, stick up one finger. If you think it's choice B, stick up 2 fingers. 3 fingers for choice C, and 4 fingers for choice D. Okay, good. I think I am unanimously seeing all 3 fingers. That is correct. You can buy 4 tickets for $40. If we go to 4 tickets on the x-axis, that corresponds with $40. So you can buy 4 tickets for $40. David?
Granted, it is like firewood if you look at the line. It does range from $50 for 5 tickets, so you just go down to $10 for $50.
Yeah, that works. You can look at any point on the graph to figure out that constant of proportionality or the unit rate. Okay, another one. This one's also for you guys to try. Russell conducted an experiment where he collected snow in a container, measured it, and then measured the amount of water in the container after the snow had melted. He created the graph below to display his findings. This one, the point 0, 0, both things are 0, so it's a little trickier, I think, on this one. So think about what you think your choice is, and let's do the same thing. Show me 1 finger for A, 2 for B, 3 for C, and 4 for D.
Big? No, I don't know. But
Okay, any final answers you want to show me? Okay. I am almost unanimously seeing choice A, which is the correct answer. I saw a couple B's. Let's talk about why B is not the correct answer, because this is the most commonly chosen answer. Choice B says that the collection of 0 inches of water results in no snow. He's not actually collecting water, he's collecting snow. The snow is the independent variable. The snow is what he's collecting, and it turns into water when it melts. So that's why choice A is correct. If he doesn't collect any snow, he's not going to get any water. And I mean, this would be true also if water could turn into snow when we collected it, but that doesn't typically happen. Okay, last objective. Use the constant of proportionality to write equations. The table at the left shows a proportional relationship between the number of minutes and the amount the customer pays for cell phone service. So if we were to check all of the ratios in this table, if we were to do 10 divided by 100 and 50 divided by 500, we're going to get the same thing because it tells us that it's proportional. Write an equation to represent the relationship. So the first thing we need to do is we need to find what that constant of proportionality is. And we do that by taking the y value and dividing by the x value. Now, in our table, it doesn't use y and x. It uses m and p. But I'm going to just write up above. The first column of the table always stands for the independent variable. So this is always x. This is always y. Even though we may use different letters, the first column is the horizontal axis on your graph. The second column is the vertical, which we know as x and y. So what would the constant of proportionality be? Brian? $10 per minute. it's not gonna be $10 per minute. Think about this, if it's $10 for 100 minutes, it can't be $10 for 1 minute. Ooh, we need to know how much it would be for 1 minute. David?
Would it be $1 for
No? Taylor?
$1 for 10 minutes?
$1 per 10 minutes, so how much would that be per 1 minute? Trey? 10 cents. So the constant of proportionality is gonna be 0.1. And you could do this on your calculator, you just do 10 divided by 100, but we know if we're dividing by 100, you might remember we moved the decimal over 2, so that just gives us 0.1. If we do 50 divided by 500, we're gonna get 0.1. If we do 100 divided by 1,000, we're gonna get 0.1, and so on. Okay, then we use K to write an equation. Our equation always looks like this. It always says y equals whatever K is, we write in, so it's 0.1 times x. So every equation we write is gonna look like this, except this number is gonna be different. So if our constant of proportionality was a 2, we'd write y equals 2x. If our constant of proportionality was 0.35, we'd write y equals 0.35x. Okay, we're going to do one of these tables together, and then I'll have you guys do one by yourself. So we're writing an equation for each table. So first we need to find what is the constant of proportionality. The first is our x, the second is our y, which is really weird because they use y for yards, and that's actually our independent variable, but they're using a letter that just has the first letter of the word yards. Okay, so what would the constant of proportionality be? Madison? No? Casey? It would be 0.5. If we're doing 8 divided by 16, that would be 0.5. So the constant of proportionality is 0.5. What would the equation be? Megan?
Y equals 0.5x.
Good. Just y equals 0.5x. So our answer is this. It asked you just to write an equation. It didn't ask you to find the constant of proportionality, so I listed it to help us write the equation, but the answer is just the equation. Okay, try the second table on your own, and then we will discuss it. Okay, volunteer to tell me what the constant of proportionality is. Reese. Good. Constant of proportionality is 5.5. Another volunteer to tell me the equation. Angelina? What's that? What, we need something on the left too. Y equals, good. Y equals 5.5x. Okay, your assignment, actually, let me see the, oops, there's your assignment. I'm gonna cut this down a little bit because it is a Friday, and I want you to just do enough so that you remember what we're doing. So just enough, really, that you can finish in class. So I'm gonna stop the recording.